Ooh, question 9. This is a tricky question, although all the physics in it is physics 11. The real challenge is seeing what's going on. So here's what's going to happen. Mass 2 is 12.5 kilograms. When we let it go, it's going to fall down to the ground. It's going to accelerate down to the ground. And when it does that, it's going to pull mass 1 up. It's going to fall 3.2 meters. So mass 1 is going to go up 3.2 meters. So mass 1 is going to be 6.4 meters off of the ground when mass 2 hits the ground. But mass 1 will be moving. It's actually going to continue in free fall on the way up to a certain height. And I need to figure out what that height there is. How am I going to figure out, and then the total maximum height. You know what, instead of calling this height, I'll call this a vertical distance. And then the total maximum height is going to be, I'll make a little note, H max is going to be 6.4 plus the vertical distance that the mass keeps going straight up. Okay, how can we figure out that vertical distance? Well, dy equals question mark. We are in free fall once mass 2 hits the ground. Mass 1 is going to keep going up, but it is going to accelerate down at negative 9.8. Negative because we're going to kinematics now. At the top, it's going to come to a stop. You know what? If I can find the initial velocity, if I can fill in the initial velocity, then I can use d equals vf squared minus vi squared all over 2a. So I need to figure out how fast it's traveling here. How can I do that? Well, how fast its initial velocity is once it keeps going up is going to be v final once it stops accelerating. In other words, I'm going to argue, and I'm going to do this over here on the right-hand side. So let's make a little note. This is while we are in free fall on the way up. This is while we are accelerating. So while we're accelerating, mass 1 starts off with a v of 0. I'd like to find that because that number is going to be that number. I know the distance that it accelerates for. It accelerates for 3.2 meters because that's how far mass 2 falls down. If I could find the acceleration, then I could use vf squared equals vi squared plus 280. How will I find the acceleration? This is a job for a free body diagram. m1g tension, m2g tension. The acceleration is going to be m2g minus tension plus tension minus m1g. That equals ma. I'll divide by m all right here. So I find that it accelerates up at 12.5 times 9.8 minus 3.6 times 9.8 all over 12.5 plus 3.6. It's going to accelerate up at 4.174 meters per second squared. A equals, what did I say, 5.4174. Which I can stick to here. 5.4174. I can find V final at the top of this 6.4, which will be V initial when it starts launching, carrying up into the air. So let's do that. V final squared equals V initial squared plus 2AD. How to get rid of a squared? Square root, and VI is 0. So I'll end up with it being the square root of 2 times 5.4174. I'll use my answer button. Times 3.2, and the 3.2 here is positive because we are ending up above from where we started. 2 times answer button times 3.2 square root 5.888. VF equals 5.888 meters per second. So that VF is that VF, which is the VI at launch. So now I can fill in D equals 0 squared minus 5.888 squared. I'm going to use my answer button, all over 2 times, and this acceleration, we are in free fall. I know we're moving up, but there's the only force acting on us is gravity, so it is negative 9.8. I'm not going to use the 5.4174. So it's going to be 0 squared plus Mr. Dewick, minus answer button squared divided by 2 times negative 9.8. And I get 1.77 meters. So the maximum height is going to be the 6.4 meters above the ground that mass 1 was when mass 2 hit the ground, plus it continues going up for another 1.77 meters, and I get 8.17 meters. Hopefully that's what the answer says too. So that's a multi-step question, but again, I would argue it's all physics 11. I didn't do anything new there. And I'm not going to ask you one anywhere near this tough. On the written section of the test, I would consider this level of difficulty fair game as a nasty multiple choice, but this question is so long, I would not give this to you as a multiple choice because you'd spend 10 minutes for 1 mark on a test, which is just not worth it. Hope that helps.